In question 8, use the following equation or rule to complete the table and the graph. So we have y equals 2x minus 4. First thing you want to identify is the constant. This is our y-intercept. Because when x equals 0, right here, 2 multiplied by 0 is 0, minus 4 is negative 4. This is the easiest one to be able to put into your table because x is 0. This is what you're to put in, negative 4. And that is also where it is plotted on the y-axis. It's called your y-intercept because it will be plotted on the y-axis. When x is 0, which means we're not going anywhere on the x-axis, we're staying at the origin, and we're going to go negative 4 on the y-axis. And that would be down. Negatives go down. And think of them as hops. Negative 1 hop, negative 2 hops, negative 3 hops, negative 4 hops. And there is the point 0, negative 4. Now we need to find the values for y for the other input values. Well, one way is just to start substituting the input values into the rule and coming up with the output. And that's what I did here. If x equals negative 2, here's negative 2, this is where x is, and I'm putting it in parentheses. 2 multiplied by negative 2 is negative 4. Negative 4 minus 4, think of it as a dig. Dig down 4 feet, dig down 4 more feet, and you're at negative 8. If the signs are the same and you're adding integers and they're the same sign, you keep the sign negative and then just add them. 4 plus 4 is 8. And so input is negative 2, output is negative 8. I also did that for 1. 2 multiplied by x, which was 1. 2 multiplied by 1 is 2, minus 4. I have more negatives than positives. I have 2 positives and 4 negatives, so I know it's going to be a negative. Signs are opposite, so I subtract. 4 minus 2 is 2, so it's negative 2. And I could do that for the remaining 2 input values to get the output values. But what I noticed here is I know that this rule or equation has a constant rate of change. So I know that for every 1 on the x, it's increasing by 1. So you can see from 0 to 1, it's increasing by 1. And the y values are increasing by 2. So if it's a constant rate of change, for every 1 increase on the x, the y is increasing by 2. So negative 4 plus 2 is negative 2. Negative 2 plus 2 is 0 for every 1 on the x. Well, I can also do that by decreasing. 0 minus 2 is negative 2. Minus 2 is negative 4. Minus 2 is negative 6. Minus 2 is negative 8. And I could go ahead and plot those. And you can see on the graph, if I start at the origin, the y values are increasing by 2, 1, 2, for every 1 increase on the x-axis, 1. 1, 2 on the y, 1 on the x. 1, 2 on the y, 1 on the x. And since it's a constant rate of change, it's going to go like that forever. Now you can see this point right here. When I was plotting it, I made a mistake. And I identified the mistake very quickly because I knew that my points are at a constant rate of change. They should make a line. Since this point wasn't on the line, I knew, I made a mistake because I went 1 and then I miscounted. It was supposed to be -1, -6, and I went -1, And somehow I miscounted and went here. And I had plotted all of these points prior to that. And I said, well, these are all going in a line. I must have miscounted. And I did it again. -1 on the x, -1, -2, -3, -4, -5. Oh, that was my mistake. I didn't go far enough down, -6. For question 9, this is the same as question 8. We need to use the following equation or rule to complete the table and graph. So here's our rule. Y equals 3x plus 1. Here's our y-intercept. Here's our y-intercept in our table, because when x equals 0, 3 multiplied by 0 is 0, plus 1 equals 1. So y equals 1. Next, I had the input of 1. So for x, see in the x table, x equals 1, I plug it in. 3 multiplied by 1 is 3 plus 1, and that's what I showed down here. 3 multiplied by 1 is the 1, that's x, equals 3. 3 plus 1 is 4. We get a value of 4. And if I plot these points, the y-intercept is on the y-axis. 0 on the x, stay at the origin, 1 on the y. Second point, 1 on the x, 4 on the y. And remember, it's easy to make a mistake. I see a lot of students say 1 is here, but think of them as hops. You have to hop 1 hop on the x, and then 4 hops on the y. 1, 2, 3, 4. And I didn't input these values for the others. What I did is I noticed that this is a constant rate of change for this equation. So for every 1 on the x increasing by 1, you're increasing by 3 on the y. So from 1 to 2, we increased by 1. So 4 plus 3 is 7. And I can also go the other way, because I can decrease by 3. 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is 2, or -2. And -2 minus 3 would be -5. And you have to make sure that it's, when you're using a constant rate, that the x values are increasing at a constant rate, and they're all increasing by 1, and the y's are increasing by 3. And I can, once I had those points, 2, 7, 2 hops on the x, 1, 2, and a positive 7 on the y. So y positives go up, positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, positive 7. And you see for this equation, it's at a constant rate, you should get a straight line. If any of these points don't line up when you use a ruler to connect them, then you did something wrong. Either you plotted your points wrong from the table, or when you solved for one of these input values, you did it incorrectly. So I would go back and check to make sure these all work and that they're all at a constant rate. You can see that they're 3 units apart on the y and 1 unit apart on the x.